Hello and welcome back. In this very last video of the section, we're going to extend the idea of magnitude and unit vectors from R2 to R3. So again, magnitude and direction being the two defining qualities of a vector, we're going to look at how those things work in 3 dimensions. So magnitude of a vector, remember that was the distance between the tail and the head of the vector. And so it's natural that we should see the distance equation in the magnitude equation. It should be essentially the same thing. And now that we have the distance equation in 3 dimensions, we get the magnitude equation in 3 dimensions as well. Big square root of the x component squared plus the y component squared plus the z component squared. And that's magnitude in 3 dimensions. It is the distance formula in 3 dimensions, keeping in mind what components of vectors are. Not too bad. Now, what if I give you 2 points, P and Q, in 3 dimensions, and ask you to find the magnitude of the vector PQ? Well, remember that the vector PQ, just the vector itself, not the magnitude of it, will look like the distance in the x's, distance in the y, or difference of the y's, difference of the z's. That would be my PQ vector. And then I want the magnitude of that, so we can come back here. This is now written in component form as a position vector, and we'll get PQ is square root, big square root, of the x component, which is the difference in the x values, squared, plus the y component, difference in the y values, squared, plus difference of the z components, squared. And that's the magnitude of PQ. Again, you can memorize these formulas, but much more importantly, I want you to understand where this formula comes from, why it has the form it does, and how you can recover that in your head without memorizing this formula. That's what I want. Now, one thing we did in 2 dimensions was, this had to deal with sort of quantifying the direction of a vector. And remember, one way that I said was going to be very useful for doing that is to give a unit vector in the direction of another vector. And so remember, in 2 dimensions, what that looked like was if I had a vector u, I take my vector u and I want to, let's say I want to produce a unit vector. Remember, that's a vector of length 1 in the direction of u. So in order to do that, I needed to first find the length. So I wanted to find the length of u, find the magnitude of u. So that's gonna, I don't even need to write it out. Find the length of u, and then scale u by that length. So this gives me, remember, this is the length or magnitude of u. And then I want a vector that's in the direction of u, but has length 1. So that's going to be u, I'll write it like this, 1 over magnitude u, scalar multiple of u. So that's the unit vector in the direction of u. And remember, the idea was if I find the magnitude of this thing now, so what's the magnitude of 1 over of this scaled vector? Well, I can pull this magnitude out. That's 1 over magnitude u times magnitude u, and I just get 1. So it's a unit vector, and because it's a scalar multiple of u, it's parallel to u. And that's exactly what we wanted. So in this way, this vector here tells us the direction of u. It's a way to specify the direction of u without giving a length. All right, that's it for this video, and that's it for the section. We're going to take these things and work with them for the rest of the chapter. Both the geometric sort of stuff we worked in space as along with the vector stuff we were talking about here. So that's in the rest of the chapter. I hope you had a good first week in this course. I will see you next week, section 13.3.